Hello, chemistry students. Today we are talking about percent composition and empirical formulas. By the end of this video, you should be able to calculate empirical formulas from mass or percent using experimental data. So this type of calculation would be done in a lab setting. Let's say you had a unknown solid substance and you use a chemical reaction to remove one of the atoms from the molecule completely. If you massed the substance before the experiment and then took the mass after the experiment, you could calculate the percent mass of that element inside the molecule. So that is percent composition. Percent composition is the percent by mass of each element in a compound. If you know the relative mass of each element in a compound, you can calculate the percent composition of the compound. So that's similar to the experiment I just described to you. In that experiment, you could discover the relative mass of each element in the compound. And the formula for doing that is mass of the element divided by mass of the compound times 100%. You could also calculate the percent composition of a compound using its chemical formula. So you would use its chemical formula along with the periodic table, and you would take the mass of element in 1 mole of compound. Now that's not quite the number right off of the periodic table. That would be like, let's use water as our example. And let's say we were calculating the percent composition of hydrogen. The mass of the element in 1 mole of compound would be 2, because the mass of hydrogen is 1 gram per mole and there are 2 hydrogens, so it would be 2. And then you would divide that by the molar mass of the entire compound. So in this example, the molar mass of the entire compound would be 2 plus 16 would be 18, and then you would multiply that by 100%. Okay, so let's practice. A compound is formed when 9.03 grams of magnesium combines completely with 3.48 grams of nitrogen. What is the percent composition of this compound? So we're going to have to do one calculation for magnesium and one calculation for nitrogen. The overall mass of the compound, 12.51 grams. So for magnesium percentage, that will be equal to 9.03 grams divided by 12.51 grams multiplied by 100%. We were given 3 significant figures. 8 will bump 1 up to 2, so our final answer is 72.2%. Let's practice that calculation again. We could subtract 72.2 from 100%, but let's get our practice in by doing the same calculation for nitrogen. We will edit that to 3 significant figures. So our final answer is 27.8%. Okay, let's practice again. Calculate the percent by mass of nitrogen in NH3. So this is the other example. We're going to have to find the mass of nitrogen and the mass of the entire molecule. So nitrogen, I'm checking my periodic table. I see that its mass is 14.0 grams per mole. Hydrogen has a mass of 1.01 grams per mole. There are 3 hydrogens in this molecule. So when I add these together, the mass of NH3 is 17.0, and I have the right number of significant figures, grams per mole. Okay, so now I have used the periodic table to find the mass of the element and the mass of the molecule. I just need to calculate the percent. We'll edit for significant figures. Five will bump 3 up. So this element has 82.4% nitrogen by mass. Okay, so now we'll move on to empirical formulas. The empirical formula of a compound gives the lowest whole number ratio of the atoms or moles of the elements in a compound. An empirical formula may or may not be the same as a molecular formula. So you use that percent by mass and you change it into a whole number ratio of the number of atoms of the elements in the molecule, okay? But it's not the same as the molecular formula because it's just a ratio of the number of atoms. So our example that I have for us is ethylene and styrene. Ethylene has a molecular formula of C2H2. Ethylene is a gas used in welders' torches. Styrene has a molecular formula of C8H8, and it is an oily liquid used in making polystyrene packaging materials. They are very different molecules, but they have the exact same empirical formula, a 1-to-1 ratio of carbon to hydrogen. The empirical formula for ethylene is C1H1, and the empirical formula for styrene is also C1H1. So you can use experimental data to find the empirical formulas, but you will need the molecular mass in order to find the molecular formula. Calculate the empirical formula of a compound that is 94.1% oxygen and 5.9% hydrogen. So what we're going to do, because we have percentage here, is we're going to assume that we have 100 grams of compound. And if we assume that, that means that we have 94.1 grams of oxygen and 5.9 grams of hydrogen. We are going to use the atomic masses of oxygen and hydrogen in order to figure out how many moles of oxygen and how many moles of hydrogen are in this compound. For every 1 mole of oxygen, there are 16.0 grams. And for every 1 mole of hydrogen, there are 1.0 grams. That means that there are 5.88 moles of oxygen and 5.9 moles of hydrogen. So this ratio is very, very close to a 1-to-1 ratio. Using experimental data like this, you can assume this is a 1-to-1 ratio. So I would take this and say the answer, the empirical formula is HO. That's it. Okay, calculate the empirical formula of a compound that is 67.6% mercury, 10.8% sulfur, and 21.6% oxygen. Again, we're going to assume a 100-gram compound, which means we will have 67.6 grams of mercury, 10.8 grams of sulfur, and 21.6 grams of oxygen. Let's convert all of these into moles. Sulfur has a molar mass of 32.06. And oxygen has a molar mass of 16.0. This makes 0.337 moles of mercury, 0.336 moles of sulfur, and 1.35 moles of oxygen. So these two look like they have a 1-to-1 ratio. And in order to figure out the ratio between these guys and oxygen, you just need to take 1.35 and divide it by, let's say, 0.337. 4.005. So the ratio of oxygen is 4, meaning that our empirical formula is HgSO4.